Good morning, everybody. We'll get started now. Just waiting for a couple more people to join, but we'll get started. You're lucky if you had a science class this morning. You may have noticed that there was an issue this morning with the YouTube. So we were all having a big problem signing on and getting our videos started. So it's nice that we're able to start this one on time because there was a huge delay for the morning class and for the science morning class. So you may have experienced that if you were in science. If you didn't, then you just hear about it. But we're very lucky to be good to go. So the plan for today and for the week and basically for the rest of this course is the following. So today and tomorrow and possibly part of Thursday, it depends on how long it takes us to get through some of this stuff, we're going to be talking about probability. On Thursday, we'll be doing statistics. There are two small things that we have to do in statistics, and then we'll do a quick refresher on the stuff that you did in CST. Wednesday, you have your situational problem. Remember, you have to be here. You have to be on time. You have 2 hours exactly. If you show up at 10:45, forget it. You lose 15 minutes. It's your own responsibility to be here on time. Only bring your memory aid, your pencils, calculators, all of that kind of stuff. Everything else will have to be in a bag on the side of the room. So your cell phone will be in your bag, not on your person. Later this afternoon, probably around 1:30, I'm going to give you a more precise list of things that will be on the SIP prob so you can narrow down your focus for studying a little bit, and that gives you a better chance to pass. Probability will not be on the SIP prob. But we can't just spend the next 2 days reviewing for the SIP prob because we have to get through this material. Probability usually shows up as a part A question, part A-B, and a part C question. So you're talking like 14% of your exam potentially. So we can't wait for it, but it won't be on the SIP prob, okay? Like I said, I'll post a list this afternoon, a more precise list. So the one I posted on Friday was very general, had pretty much everything that was fair game, but I'm going to narrow it down just to make it a little bit easier on you so it's not as intense to be studying for. Although all of that material is fair game for the final, so you need to be making sure that you're preparing for that. Are there any questions specifically about the SIP prob? Okay, no questions specifically about the SIP prob? Perfect. Okay, so today is probability, tomorrow is probability, Wednesday's SIP prob, Thursday stats / probability / review, depending on, it depends on our pacing for the rest of the week and how quickly or slowly we get through things. Friday will be a review period in the sense that I'm going to go over a lot of different exam level problems. So on Friday in the notes folder, I posted 2 kind of mock finals, some like practice final kind of stuff. So we'll go over a lot of those questions, and we can go over a lot of the assignment questions because, like I've said to you before, the assignment questions are exam level questions for the most part. So the Google Forms are representative of part A questions that you could get, and the Google Docs are more representative of mostly part C, but some of part B as well. So we'll go over a lot of those questions, and we will go over a lot of the practice final questions as well. I'll be posting solutions to those 2 sometime during the week. Not today, but sometime during the week, you'll get the solutions for those as well. When is your final exam? Good question. So if you go to the school board website, I'm going to have to screen share because clearly you're not seeing what I'm seeing just yet. If you go on the school board website, just Leicester v. Pearson School Board, there's this little sunny sun with a face, summer school. And then right at the bottom of this box here says July 2017 supplemental exam schedule. On there, it gives you the exam schedule. So if you're not just taking math, if you're taking something else, it'll all be here. But under Tuesday, July 25th, you see Sec 4 Math C2 reasoning. So that's the final exam, the ministry exam. and Sec 4 TNS, that would be you guys, but regardless, all the Sec 4s right at the same time. So it's here on Tuesday, July 25th from 9 to 12. When you come in, they'll be giving you a room for your final. Remember also that for the SIP prob, we're in room 334. So I'm going to post that a couple of times between now and Wednesday. Do not show up at this room. No one will be here waiting for you. So this is always on the school board website if you forget, but I'll post it in the classroom too, just in case. So any questions about SIP prob or final? So Friday is our last official class together. After that, I'll be reachable by email as per usual. I'm always reachable by email, but specifically after Friday's class, you can send me an email. I'll try to answer all the emails, and I'll try to be on the computer on Monday night before the final as long as possible. Obviously, I'm not going to stay up till 3 in the morning, neither should you, to answer emails, but I'll try to stay on and be accessible as long as possible and to try to answer your emails as immediately as I can to be just available for you before the final. Yeah, is there a list of things that could be on the exam? I posted a list, so in the course outline, which you can find in the notes folder, that was the list of the new material that we would be covering and the CST material that you were responsible for. So we'll take a look at that again, but you could take a look at that yourself over the next couple of days when you're prepping your memory aid. That'll help you guide yourself. When our exam is graded, do they take our mark if it's a passing grade? That depends, like that's a good answer. It depends on your school. So they'll just let you know if you pass or if you fail, like what your grade is, and then what your school and what you decide to do with that is totally up to you guys. All I see is the pass fail, kind of what's happening with you now, okay? But let's not think like that. Let's think that we're all gonna pass because we're all gonna really study really hard and ask questions and get ready and go over all the stuff. We're going to be great. So let's not think about the failing case scenario. Let's just think about the passing case scenario and put all our energy into the passing case scenario. Sound good? Sounds good to me. All right. So any questions about that stuff? Pessimism is life's greatest philosophy. That's funny. All right, final exam, SIP prob, anything like that? Or are we ready to go? Whoa, by ready to go, yeah, exactly. So by ready to go, I do mean I'll be taking questions now for past material to go over quickly. So I'll wait a minute and I'll just see which questions come up and then we'll go over those. So if you have a question that you want to go over, now would be the time to be posting that in the chat. Okay. Okay, I'm just waiting one more minute and then we'll get started. Okay. Hey, all right. We'll start off with this one, and then we'll jump to the questions on matching bases and assignment 9 and 10. So assignment 6, number 1 says you're given this rule, find the equation in symmetric form and convert to general form. So remembering that symmetric form is x over a plus y over b equals to 1. So we look for the x-intercept and we find that it's -5 and the y-intercept is 6. So what I'm going to do here is I'm going to multiply by a number that's going to cancel both of these bases out. Or another way to look at this is I'm going to multiply by -5 and then I'm going to multiply by 6. So it's either you do 30 once or you multiply by 5 and then by 6. So I'll multiply by 30. And just to give you visually what this looks like, if I distribute this in, this becomes 30x divided by -5 plus 30y divided by 6 equals 30, right? Because the 30 distributes to all 3 terms. 30 divided by -5 gives me -6. 30 divided by 6 gives me 5. And this is just 30. Now I need one side to be 0 and I also need the a term to be positive. Right now it's negative, so I'm going to move this to the other side. That gives me, this turns to positive, the 5 turns to negative, and the 30 stays positive. When I multiply this, because you're not multiplying by 30 over 30, you're multiplying by 30. So multiplying by 30 over 30, you're not actually changing the fraction. So you only multiply the numerator. So in this case, this is just a case of multiplying fractions. If you're multiplying 10 over 3 times 5, remember that this is 5 over 1, so you do top times top and bottom times bottom. You don't put the 5 over 5. Okay, so that's assignment 6. Now I have a couple of questions. Matching bases from the exponential handout. Right. I don't know what is happening. Some of these are really hard, okay? So if you're not getting most of them, that's okay. There's not really one that I want to do. We'll do this one. It's a little bit more complicated than you would handle, but that's okay. 6 to the negative 2x times 6 to the negative x equals 1 over 216. So when we're matching bases, we need something to the something equals like a to the c equals a to the d. So we need the same base with exponents, so only 2 terms. So the first thing I'm going to do is I'm going to put this together. Remembering that when we multiply terms, we add the exponents. So this gives me negative 3x. Now I want to know if I could write 216 to the power of 6 So it's 216. 1 over 216 is 6 to the power of negative 3. So that's something you would just like guess and check on your calculator. Once I have the same base, I just drop the bases and I make the exponents equal to one another. So I have negative 3x equals negative 3. And I divide by negative 3 to give me x is 1. Is that good? Chances are very likely that you'll be using log relationship and not matching bases. Yeah, this is the one that says not requiring logarithms. Okay. Next. Next we have assignment 9. I have question 2 and question 3. And then I have number 1, 2, and 3. And then assignment 10, number 2. Cool. Okay, so this is assignment 9, number 1. So this is an example of a part B question you could get. So you're solving this equation. So I'm going to move this 10 over. And I need to divide by 2. So 3 to the x equals 5. And then I need to flip this using my log relationship. So this x drops down. The 5 goes on the top, and the base goes on the bottom. So when I type that into my calculator, I get log of 5 divided by log of 3, which gives me 1.46. Is that good? Okay. Question 2. 324 equals 4, 3 to the x minus 6. So again, I want to be using a log relationship, but before I do that, I'm going to have to get rid of this 4. So you do 324 divided by 4 gives me 81. So then I use my log relationship, which says that this drops. I take the log of 81 and I divide by log of 3. So when I type this into my calculator, I get 4. And then all I have to do to solve for x is add 6. So 4 plus 6 gives me 10. Okay. So then we have number 3. Number 3 says, on the same day in January 2010, Daniel bought a truck and Jack bought a car. Since then, the value of each vehicle has decreased annually with respect to its previous year's value. The following function describes how the value of Daniel's truck has decreased. So this is Daniel. We have y equals 31,000, 0.89 to the x. Jack paid $25,000 for his car in January 2010, and his car has been depreciating at a rate of 12% annually. So Jack, we could make Jack's equation. So we have that he starts at, he bought his truck for $25,000. It's depreciating. We're going to still use x as years and y as value. It's depreciating in years, so every year. So we're just going to put D as 1, but we don't really need to deal with that. And it says it's losing 12% per year. So it's a percent decrease. So this gives me 0.88. So his rule is 25,000, 0.88 to the X. It says when Daniel's truck is worth $15,406.42, how much will Jack's car be worth? So the 15,406 goes in as a Y into Daniel's equation. And we're going to find out when his car became, his car's value turned to 15,406.42. So the first thing I'm going to do is divide by 31,000. So I take my 15,406.42 divided by 31,000. And that gives me, try to keep as many decimals as possible. Or if you can use your answer button for this next step, that would be fantastic. So you get X is log of 0.49698 divided by log of 0.89. So you type that in and you get 6. So after 6 years, his car, Daniel's truck, reaches a value of $50,406.42. So they want to know how much Jack's car will be worth at the same time. So we know that 6 years have passed. So I just plug in the 6. So 0.88 to the 6 gives me, again, keeping as many decimals as possible. So this gives me $11,610.10. So that is a stereotypical part C question with exponential functions. The only thing that you could expect to handle a bit differently now would be that you would have the D involved that's not a 1. But this is still a type of question that you could be expected to handle. So the only thing that would be different is you'd have a D here, which would change this equation, and that would, nothing else would change. Okay. The D, again, remember the D means the period of the increase or decrease. So if it said that it was losing 12% of its value every 6 months, 6 months is half a year, so D would be a half. Or if it said it loses 15% every 2 years, D would be 2 because it's every whatever years, whatever that whatever is becomes our D. And that just plops into our equation, and then we just solve things differently. Okay, so that's it for assignment 9. Okay. Assignment 10, question 2, and then we'll move on. So assignment 10, question 2. 2 bacterial cultures are studied in a lab. The number of bacteria in culture A doubles every 30 minutes. So we're going to say culture A. We're going to call X as hours and Y as number of bacteria. So culture A, it doubles. So my C is 2. We don't know what our A is as of now, but it doubles every 30 minutes. 30 minutes is half of an hour. So as of right now, we have Y equals AC to the X divided by D. So here I get Y equals A2 to the X. When I divide by 1/2, just to make this a little bit easier to see, remembering that when I divide by 1/2, this is the same thing as multiplying by 2. Culture B says it's doubling every 20 minutes. 20 minutes is a third of an hour. So we get A, 2 to the x divided by 1/3, and we can apply the same thinking. If I divide by 1/3, that means I'm multiplying by 3. Because remember, if I have x divided by 1/2, that's the same thing as if I change this to a multiplication and I flip this fraction, so it's x times 2, which is 2x. And then I apply the same thing here. It's x divided by 1/3. So it's x times 3, which is 3x. And that's just visually easier to look at and mathematically easier to solve if you've written it like that. The problem is we don't know A for either one of them, but we know for culture A, after 1 hour, there are 384 bacteria, and for culture B, after 1 hour, there were 24. So I can use these as points just to solve for my A value. So 384 equals A, 2 to the 2 times 1. Can zoom out for a second here. Hey, I don't know why it keeps doing that. Okay, we're good to go. So 384 equals A, 2 to the 2. Well, we know that 2 to the 2 is just 4. And I divide by 4 to give me an A of 96. I do the same thing here. 24 equals A, 2 to the 3 times 1. So I get A, 2 to the 3. 2 to the 3 is 8. And I divide by 8 to give me 3. So now I have both of my rules. Y equals 96, 2 to the 2x. And this is y equals 3, 2 to the 3x. Now it says, the question says, determine the number of hours since the beginning of the experiment required for these two cultures to have the same amount of bacteria. So same amount of bacteria means the y's are equal. So we know when the y's are equal that we just take this and make it equal to this. It's kind of like comparison method, right? And by kind of, I mean it is comparison method. It's just a little bit trickier. So this is actually the trickiest part of this problem. So what I'm going to do is I'm going to divide this by 2 to the 2x to get rid of it here. Remember that when we have 2 to the 2x divided by 2 to the 3x divided by 2 to the 2x, this becomes 2 to the 3x minus 2x, which gives me 2 to the x. And then I'll divide by 3 here, which gives me 32. Now this is something I'm familiar with, so I can change this using my log relationship. Log of 32 divided by log of 2, and you get that this is 5, which means that 5 hours after the start of the experiment, these two things had the same amount of bacteria. Any questions? You shouldn't. Log 32 divided by log of 2 is 5. Can you send me a picture of your work and I'll take a look at it after, because this is what you should get for sure. No, you got it right. Log 16 over log 2 would be 4. Oh, whenever I type log equals into my calculator, I always get something different. I'd have to see your calculator. So if you want to send me a picture of your calculator, because the different calculators input things differently sometimes. So if you send me a picture of your calculator, I'll just like type out how to use it to make sure that you're using it properly. Okay. Any other questions? Cool. So on Friday, we ended off just starting probability. We did start it. We started it. How far did we get? We didn't start it, did we? Okay. All right. So we're going to do this quicker. We talk about probability in Sec 1, 2, and 3. More so 2 and 3. But anyways, we're going to take a look at that stuff, and then we will take a look at, I'm not even sure if we'll get to the new stuff or the new important new stuff today or tomorrow. Definitely tomorrow, but potentially today, we'll see. So terminology that you need to be familiar with. A random experiment is an experiment that you cannot predict the outcome of. So just so we're all on the same page, we're in class 10 notes from Friday. We're right at the beginning of probability. So a random experiment is an experiment that you cannot predict the outcome of. So when I flip a coin, I know that it could be heads or tails, but I have no way to know what it's actually going to land on. And when I roll a die, I know that it could be a number between 1 and 6, but I have no idea to predict, no way to predict what it's going to end up as. We call the universal set, which is represented either by this symbol or by this symbol, depending on what book or what the government decides to use. You can use them as both. And that is the list of all possible outcomes in an experiment. So if your experiment is rolling a die, your universal set is all the possibilities. So 1, 2, 3, 4, 5, and 6. An event is a subset of outcomes. So I'm taking a certain case scenario of the big event or the big experiment and saying, this is the event I'm looking at. So if you're rolling a die, some examples of events would be rolling an even number, rolling a prime number, rolling a number less than 7. So these are all examples of events that you could say. A certain event is an event that is guaranteed to happen. So if I say my event is rolling a number less than 7, that's a certain event because no matter what I roll, it's less than 7. Event B, rolling a multiple of 8, is what we call an impossible event because no matter what I do, I can never get that. I'm never going to roll a die and magically get a multiple of 8, which by the way is our multiples if we remember 8, 16, 24. all the 8s when we're counting by 8s. So it's impossible. So we call that an impossible event because it can never happen. We're just going to review that you do geometric probability in Sec 3. So I just want to do a quick review of what this looks like. So geometric probability was when you had different geometric shapes and you were taking a specific area or volume of a shape and saying, what is the probability of landing in this given area or in this part of the volume, or on a length, which you really didn't see length, but it was still part of it. If you have a pointer, what is the probability of it, the pointer landing on a given section of line? So the way we do this is not different. The idea is always the same, but the dimensions are different. So for a one-dimensional length, you have the probability, like it's the pointer question where you have a pointer over a line and you're saying, what is the probability of the pointer landing on a given section? So you have the length of the section divided by the total length. So that was your geometric probability. So the probability of A is the event A. So it's whatever A is. So in this case, we're talking about, for example, you have, let's say, this problem where this to here is A, but this is the whole line. So the probability, if I have a pointer that's going over here randomly, what's the probability when I stop it that it's going to land in the section of A? So we take the length of A over the total length, and that is going to be the probability of me landing in the A section. For areas, it's usually we have a shape and we have a shaded area and a non-shaded area. So what is the probability of me landing in a certain subset? So like in this picture here, it could be what is the probability of me landing in the shaded area. It could be what is the probability of me landing in the non-shaded area. But whatever it is, it's the area that I want over the total. Same thing for three-dimensional. In three-dimensional, it's hard to draw a picture of this because with 3D shapes, it's a little bit more difficult. But for three-dimensional, you have a volume and you have a specific like subset or region of the volume that you want and you don't want the rest. So you're like throwing a ball into a box, but there's a smaller box in it and you win a prize at the fair if you throw the ball into the smaller box. What is the probability of that happening? So you would take the volume of the small box divided by the volume of the whole big box. So if we took a look at this example, just to give us a little refresher. So find the probability of landing in the shaded section. So we have two-dimensional figures. So we have areas. So circle radius is 20. So area being pi r squared gives me 20 squared times pi, we'll say 1256. The square side measures 9, so the area is 9 squared, which is 81. Triangle, we have base times height divided by 2 is 3 times 2 divided by 2. Well, sure, you can write it that way too. 2 times 3 divided by 2, which gives me 3. So if I want shaded view, so if I want the shaded region, want the probability of shaded, I'm going to take the area of shaded divided by the total area. So the area of the shaded is going to be the circle minus the square plus the triangle, right? Because we're taking out the square, but we need to add back in the triangle over the area of the circle. So I had 1256 minus 81 plus 3 over 1256. So if I do 1256 minus 81 plus 3, I get 1178 divided by 1256. And if I reduce that, just reduces to 589 divided by 628. That is CST. Too bad we're doing TS. All right, so that is just a quick review of geometric probabilities. So you're not necessarily going to be specifically tested on this, but you have one example in the handout, which we'll probably only get to tomorrow. But it uses the idea of geometric probability and to do something else. So it's usually the something else that you're tested on, but you could need to know this to do those problems. Okay, so we're just going to quickly look over the difference between arrangements and combinations. So the difference between an arrangement and a combination is that a combination is any grouping of something. So in an experiment, first to start, in an experiment that requires several steps, if the first step can be performed in A ways and the second step in B, the number of outcomes is the number of outcomes in step 1 times the number of outcomes in step 2 times the number of outcomes in step 3, ... depending on how many steps we have. If we have 10 steps, we're multiplying 10 numbers. If we have 20 steps, we're multiplying 20 numbers. For example, if we have a menu, we have 3 appetizers, 4 entrees, and 5 desserts. How can we combine a menu? So I have 3 appetizers, I have 4 entrees, and I have 5 desserts. So I'm going to multiply those. So 3 times 4 times 5, that gives me 60 different meals that I can create. A permutation is something different. So in theory, with the previous question, if I really, really, really want my dessert first, and then I decide to eat my appetizer and then my entree, I still have the same meal if I decide to, like if I have, let's say my appetizer is Caesar salad, and my entree is chicken, and my dessert is chocolate cake. Doesn't matter if I ate the chocolate cake first and then I ate the salad and then I ate the chicken. I'm still eating the same 3 things. So we call that a combination of things. A permutation is when the order matters for something. So for the other one, it didn't matter what part of the meal I ate first because we were looking at what meal you could have total, not which one you're eating in order. But a permutation is an ordered sequence of objects. So order matters. So for our example before, if we're talking about a permutation, then having the chocolate cake first or last creates a different meal, which obviously it doesn't, so we wouldn't use that type of example for a permutation. But the idea is that ABC is not the same as ACB. We have the same letters, but the order is different, so we cannot consider that the same outcome. So what we do is, if we have n different objects that we're ordering, like putting in order, for the first slot, whatever the slot may be, I have n objects to choose from. So for step 1, I have n objects. But for step 2, I don't have n anymore because I've placed one already. So I take one away. So for step 2, I have n minus 1 objects. To do the third place, I would take away 2 already because I've already placed the first and I've placed the second. Now I'm placing the third. So you're constantly taking 1 away to put something in its place. So we continue doing this until we go right to the end. But this is super inefficient to represent it this way. So we actually have a representation. So we call this, if we go all the way to 1 from n, where we're taking away one number and we're multiplying, we call this n factorial, and we have a little exclamation point beside the letter. Now, or the number. On some calculators, you have the factorial sign. So I have the Sharp calculator, and on the Sharp calculator, the factorial button is second function 4. So this will do it for you, but we're just going to practice doing this quickly. Our own. So 4 factorial, what this means is I take 4 and then I multiply by 1 minus, which is 3, and 2, and then 1, and that gives me 24. Yes, 0 factorial is 1, but we're not going to get into the mathematical reasoning behind that. You're never going to be asked to do, you can't arrange 0 objects, so you're not going to be asked to do that. That's like a mathematical side note, okay? So you could also write this as 4 factorial, and your calculator will do this. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, which gives you 6 factorial. And if you do that out on your calculator, you get 720. $12 factorial, same thing, gets annoying to write. If your number becomes too big, your calculator won't be able to support it. But you'll never have to do something that crazy. So 12 factorial gives me 479001600. So what is this used for? We'll just change this to 5 because the next one's 4. How many ways are there to place 5 books on a shelf? So I'm doing the first position, or the first position, I guess. Doesn't matter really what you call it. In the first position, I have 5 books to choose from. But in the second position, I only have 4 left to choose from. And in the third, I have 3. In the fourth, I have 2. And in the last, I have 1. So that gives me 5 factorial. So if I do 5 factorial, there are 120 different ways I can arrange 5 books on a bookshelf. So if you're bored one afternoon, you could try to figure out what all these 120 are. Preferably wait till after your exam, because if you're doing that on your afternoon, you definitely could be doing math problems instead. Way better use of time. 4 people are applying for 4 different positions. Determine the different possibilities with different people occupying the different positions. So again, I have position 1. I have 4 people to choose from. But once someone has filled position 1, I only have 3 people left to choose from. And once someone has filled position 1 and position 2, I only have 2 people left to choose from for position 3. And then the leftover gets position 4. And like we saw before, this is 24. So remember that a combination, the order does not matter. So for an example, a bag of marbles contains 7 blue, 5 green, and 8 red. Find the different combinations of marbles if we pull 3 marbles out. So they're not saying, what do we get on the first one? What do we get on the second one? What do we get on the third one? In this case, if I pull out a blue and then a red, it's the same as pulling out a red, blue, blue. That's still the same combo. We don't care which order we pull them out in, so these are the same. So in this case, you would actually have to start writing out, okay, I could get a blue, a blue, a blue. I could get a blue, a green, a blue, a red, a blue, and dot, 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 and it will take you a long time. But the idea is that for combinations, this is the same as blue, blue, green, or green, blue, blue. And this is the same as blue, red, blue. It's the same as blue, blue, red, dot, 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 dot. So we'll look at a more efficient way to do these things later on. But for now, it's just understanding the idea that if it's in order, it's different than if it's not in order. Any questions so far? Okay. So we're just going to take a look at 2 quick examples here just to really understand the probability thing. A coin is tossed 3 times. Provide the possible outcomes for getting a total of 1 tail. So I could get the tail on the first toss and then get heads, heads. I could get the tail on the second toss, or I could get the tails on the third toss. B, getting a tails on each toss. There's only one case scenario where that happens, in which you get a tails every single time. So remembering that these events are subsets of our universal set. And our universal set would be all of the different possibilities when we're tossing a coin 3 times, which would be a big pain to have to write out, but you could do it. So we're not going to actually do this one. We're just going to talk about it. So Vanessa shoots a basketball 3 times. An S would be a success. F would be fail. So if you started to give all the sets of the outcomes, she could get a success, a success, a success. She could basket, basket, fail. Basket, fail, basket. Basket, fail, fail. And you'd have to go through all the different possibilities. We're not going to do that, but you would just have to go through and say, okay, what kind of different combos can we have here? This is a little difficult, but give a certain event would just be like she shoots the basketball and something happens, you know, like she for sure is going to shoot it and either it goes in or it doesn't. Give an impossible event, that would be if she gets 4 successes, right? She only shoots the basketball 3 times, so she can't get 4 successes. So that would be impossible. Okay. Okay, so here's where we're kind of doing some new material, and this is the stuff that was in the, what's it called? This was the stuff that was in assignment 10. So on the doc and on the forms. So this is the stuff that will help you with that. Odds and probabilities. So these are things that you actually hear of a lot. So especially relating to like sports or racing, stuff like that. The odds of something occurring and the probability of something occurring. So you hear like the odds of team A winning or 5 to 10, 5 to 11, or the odds of Sidney Crosby scoring a hat trick are 1 to 9, you know, like, so there's different odds, or you could say the probability that the Penguins will win the Stanley Cup is this. So when you're saying odds and probability, you're representing the same information in a different way. And these ways can be converted to one another. So we're going to look at odds first. So odds is always written as a ratio using the dot dot, okay? So what odds are, it tells us the likelihood of an event occurring. So when we say the odds for, we have chances for at dot dot chances against. So for example, 2 to 3. That's an example of an odds for something. Odds against would be the chances against ... chances for. So this could be like 4 to 7. Really doesn't matter. Or 9 to 1. It doesn't have to be the smaller number first, because what it represents is either the chances for to the chances against, or the chances against to the chances for. So we'll take a look at a couple of examples of these. The odds of rolling a 3. So remembering that we have 1, 2, 3, 4, 5, 6. How many of them are 3s? Only 1. How many are not 3s? 5. So the odds of rolling a 3 are 1 to 5. The odds of rolling an even, there are 3 evens, 2, 4, and 6, and there are 3 non-evens. When you see the odds against, you're doing it backwards. So put your ... We want a number less than 5. So a number less than 5 is 1, 2, 3, 4 of them. That's going to go here. And how many are not less than 5? There are 2 of them. Because the odds of rolling a number less than 5 would be 4 to 2. We just flip them around to get the odds against that thing. Does that make sense? Okay. So what is the relationship between odds and probability? So odds and probability, it can be written and converted to one another. So odds, the question is, when it's 4, it's the number that we want to the number that of things that don't give us what we want. And odds against are the number of things that don't give us what we want to the number of things that we want. So what probability is, we're going to do quite a few of these examples, okay? So hopefully it'll be a bit more clear. The probability, the relationship between these is a probability of something. So we looked at this when we talked about geometric probability, is we want the number of outcomes favorable to A. So whatever we want the number that we can get. So if it's rolling an even, there are 3 of them that are even. So that is the number of outcomes favorable to what I want. For probability, we want over the total number of outcomes. What this looks like is the odds for divided by odds for plus odds against. Because the odds for and the odds against, they sum up to give me the whole thing. So you've actually used this type of calculation before. When you did distance, just lied. When you did division point, where you had, okay, it divides the line in 2 to 3, which means you plugged in 2 over 5, right? It's the same idea with odds and probability. So 2 to 3 becomes 2 over 2 plus 3, which gives me 2 over 5. Because 5 is the total. If it's 2 to 3, that means 5 is the total, so it's 2 over 5. Just a couple of things before we start to remember for probability. Probability is a number between 0 and 1. So if you get a probability that's negative, you've done something wrong. And if you get a probability that's bigger than 1, you have still done something wrong. Is that good? Cool. So what are the odds for, odds against, and probability of rolling a prime number on a die? So I'm going to take a quick survey. because some of you learned 1 is a prime number and some of you learned 1 is not a prime number. So tell me prime or not prime on the survey or on the chat. Prime or not prime? 1. Go. Okay. Okay, so for the purposes of our example, we're going to call 1 a prime number. But I'm going to write that just so we're all clear. Okay, so we're going to call 1 a prime number. So what are the odds for, odds against, and probability of rolling a prime number? So if 1 is the prime number, how many prime numbers do we have? So odds for, well, we would have 1, 2, 3, and 5. So you would actually have 4 prime numbers. How many non-prime numbers would there be? 2. That means the probability of prime would be 4 over 2 plus 4, because the 2 plus 4 will give me the total. And that gives me 4 over 6, which is 1 over 2 over 3 dose. The odds against prime, I literally just take these two and I flip them. Because when the odds are against it, we want what it's not to what it is, because that gives us the odds against us getting that. Good? Cool. What are the odds for, odds against, and probability of picking a king out of a standard deck of cards? We remember 52 cards in a deck. Prime number is any number that whose factor is only 1 or itself. So like 4 can be divided by 2, so it's not prime. 6 can be divided by 2 and 3, so it's not prime. So the odds of a king, how many kings are there? 4. How many non-kings are there? 48. That gives us a probability of king of 4 divided by 4 plus 48, which is 4 out of 52. And you can reduce this to 1 over 13. So this would be 4. Odds against, we just flip the numbers. 48 to 4. Number 3, a card is drawn from a deck. What are the odds and probability for the following? For drawing a queen, odds for drawing a queen. So we have how many queens? We have 4. How many non-queens? 48, which gives us a probability of 4 over 48 plus 4 gives me 4 over 52. That gives me 1 over 13. For drawing a heart, how many hearts are there? There are 13. How many non-hearts are there? 39. So the probability of a heart is 13 divided by 13 plus 39, That gives me 13 over 52, which is 1 over 4. Guys, stop using each other's names, goodness. You have the infinite world of names you can choose from when you're going to use each other's. Good grief. Against drawing an even card. So against means how many non-even cards. So remember, the even card would be the 2, the 4, the 6, the 8, the 10, and the queen for card players is usually considered an even because it represents a 12. So how many non-even cards are there? Well, we could just do the evens. So we have 4, 8, 12, 16, 20, 24. So how many non-evens would we have? 28. Yeah, all right, that works too. So the probability of even or probability of not even, oh God, I keep saying not even like it's a thing. The probability of odd would be 28 over 28 plus 24, which would be 28 over 52. And that reduces to 7 over 13. How do we feel about odds and probability? Converting one to the other and everything. Okay. Well, pointless math. You can feel it's pointless, but you still have to do it. This one's actually, like, you actually see this a lot. Like, there are some of them when you're like, well, I'll never see this again in my life. But this you actually see. Lots has to do with sports, sporting events, stuff like that. So that, we're going to do number 5 before we move on. You have a bag of purple, green, and orange marbles. There are 300 marbles in the bag. The odds for getting an orange is 1 to 4. The odds against getting a green is 10 to 3. We're going to change this 3 to a 2. How many of each colored marble is there? So we're going to do orange. And we are going to do green. So for orange, we have 1 to 4. So the probability of orange is 1 over 1 plus 4, which is 1 over 5. If there are 300, 1/5 of them are orange. So I take 1/5 of 300, and that gives me 60 orange. The odds against getting a green are 10 to 2. So odds for would be 2 to 10. So the probability of green would be 2 over 2 plus 10, which is 2 over 12, which is 1 over 6. So again, 1/6 of the marbles are green. So I take 1/6 times 300, and that gives me 50 green. I want to know how many purple. So purple is going to be 300, the total, minus the number of orange, minus the number of green. Well, I just found the number of orange to be 60, and I found the number of green to be 50. So if I do that subtraction, we get 190 purple marbles. So on Forms 3, you have one question pretty much exactly like this. So just follow these steps and you'll go through it. On docs for assignment 10, number 3, you have a question that is comparing the probability of winning games. So you have 4 different games and you're comparing, you want the game that has the highest probability of winning. But for some of them, you're given probability of winning, probability of not winning, which I guess is losing. I don't know why I keep doing that. And then you're given odds in 2 cases. So you have to compare. If you're comparing, you should be turning them all to probability and then taking the one that has the highest number. So now you have all the tools to complete assignment 10. Cool. Not that we're done. How to do which question? Number 3 on assignment 10. Okay. If you take a look at it again, you have 4 different games. I'm not going to do it for you because this is the whole point of the assignment is for you to try it on your own. But you have 4 different games. One, you have the probability of winning. One, you have the probability of losing. One, you have the odds of winning, and one, you have the odds of losing. So you're going to be doing essentially calculations like this, where you're converting odds to probability. And then you're comparing the probability of winning for each of the 4. And then choosing which game has the highest probability of winning. So if you're still confused, we can go over that problem tomorrow, but I do want to give people a chance to look at that problem before we actually just do it. So moving on, that gives us the end of class 10 notes. So we shall be starting class 11 notes now. All right, so the next thing we are going to be doing with probability is we are going to be using Venn diagrams to represent our different probabilities. So chances are that you have seen Venn diagrams in some of your other courses. We're just going to formally reintroduce it in case you haven't. Like you may have seen this in science before and all that kind of stuff. But like I said, we'll reintroduce it just in case you haven't, and we're going to formally talk about it and then see how Venn diagrams relate to probability. So Venn diagrams, when you have this big situation, and the big situation is the universal set. So the box is a universal set, okay? So our box is our universal set. I'm not going to use red because I'm using red for something else. So we'll say green. So that is our universal set. A is some sort of event, and B is another sort of event. Now, sometimes event A and event B overlap. So in a Venn diagram, this is how it looks, where you have this middle that is overlapping. We call this the intersection. So here we have A intersection B. So that's the middle part. So this symbol means intersection. And what this means is A and B. So anything that is both in A and in B. So the left circle is the A, The right circle is the B. Where it overlaps here is A intersection B, which means A and B. So anything that is in A that is also in B falls there. So let's create the Venn diagram for this one. So we're going to call, this is our universal set. So rolling a prime, again, we're going to be using 1 as prime. So 1, 2, 3, and 5. Rolling an even would be 2, 4, and 6. So in A, I get 1, 3, and 5. In B, I get 4 and 6. And because 2 is in both of these things, it falls in the intersection. Guys, just all change your name to something else, please. It's crazy. I don't care what it is. Just don't use each other's names or variations of each other's names like that. Just change them. So in this case, everything, all the numbers happen to fall in A or in B or in the intersection. Okay? We call incompatible events mutually exclusive events when there is no intersection between. So if A and B are incompatible, that means that this center portion here is going to be empty. So we call this the empty set. So for example, if we're rolling a number less than 3, we'll call this A. So A would be 1 and 2. And rolling a number greater than 4, we'll call that B. And this would be 5 and 6. So I have 5 and 6, not 56, or 5 and 6 in here for B. I have 1 and 2 in for A. Universal is here. So then I have 3 and 4 on the outside that doesn't fit into A and doesn't fit into B. And we see here that these are empty. So we call event A and event B mutually exclusive. What is the union? Well, the union, written like this, call this union. What this means is A or B. So anything that's an A or B. So let's see what this looks like visually. Rolling an even number, we'll call this A. So A, an even number would be 2, 4, and 6. Rolling a number greater than 3. So all of a sudden, the 4 and the 6 aren't going to go there. The 4 and the 6 are going to go here. And on the outside, we're going to have the 1 and the 3 that don't fit in anywhere. Thank you. Thank you. Oh, boy. That's fine. Okay. So A or B means anything that's an A or in B. So A or B means anything that falls within these circles. So A or B is actually 2, oh, that should be a 6 here. It is actually 2, 4, 5, and 6. Make sense? I'm interpreting your silence to mean yes. Complementary or contrary events are 2 events that have no overlap. And then when we add them together, they give us the whole universal set. So in order to be a contrary event, which is represented by, this means A, and this is not A, which you can represent either with the A with the hat, with the straight line hat, or A prime. So either one of those just means not A. And basically you can have no leftover. So for example, rolling an odd number, if we call this A, would be 1, 3, and 5. Rolling an even, B, 2, 4, 6. There cannot be, for these to be complementary or contrary, there can't be anything in here, and there can't be anything on the outside. Because if there's anything on the outside, that means that these two together don't make up the whole universal set. And if there's overlap, that means there's extra than the whole universal set. So in this case, we can call event B, we can call it A prime, because then A and A prime together give us the whole universal set, gives us all of the different possibilities. Does that make sense? When you are doing problems, you just write out the universal set, create your Venn diagram, and answer the question. And it's not necessarily going to tell you to use a Venn diagram. You just have to be comfortable enough to use it, or you just have to know to use it. Make a Venn diagram and find A prime for the following situation. You roll a 6-sided die, and event A is rolling a number greater than 2. So event A would be 3, 4, 5, 6. So we want A prime. So we need everything that's left over. So A prime would be 1 and 2. And then you just want to translate this into words. So you could say rolling a number, not number, number less than 3. So then A and A prime are contrary events because together they make up the whole universal set and there's no overlap and nothing left over. This one's a little trickier, and the reason that's why we're going to do it this way, we're going to create the Venn diagram. So we have A that is rolling an odd number. So what are the odd numbers when we're rolling? We have 1, 2, 3, 4, 5, 6. So for rolling an odd number, I have 1, 3, and 5. But event B is rolling a number greater than 3. So what are the numbers greater than 3? We have 4, 5, and 6. Since 5 exists in both, it goes into our middle. What are we left with? We have 2 on the outside. It helps if you say you don't understand something to tell me what you don't understand, like what part of it. And please don't say all of it. Like, is it how to make the Venn diagram, what to put where, what the events mean, like where to place things? Okay, so whatever, okay, so an event, so you have an experiment where you're doing something. So in this case, we used rolling a die a lot. So that's our experiment, is what's going to happen when we roll our die. An event is different possibilities of things we can get. So an event could be rolling an even number, because then we could get a 2, a 4, or a 6. So that is an example of an event. An event could also just be rolling a 2, rolling a 6, rolling a factor of 6. So all of these different case scenarios for our experiment are called our events. Each of these different events are represented by, in a Venn diagram, by a circle. So you're going to find each of the possibilities for that specific event, each of the different outcomes for that event within this circle. Now, if you see the circle on the left in this problem, that's event A. So anything that's in event A is a possible outcome for A. So in the A, you've got 1, the 3, and the 5. And those are your odd numbers. So anything in the 1, the 3, and the 5 will go in A. The circle on the right is event B, which is rolling a number greater than 3. The numbers greater than 3s are the 4, the 5, and the 6. The reason that the 5 goes in the middle is it is both an odd number and a number greater than 3. So it fits into both different events. So it goes in the middle. 1 can't go in the middle because if 1 is in the middle, that is saying that 1 is a number greater than 3, which it's not. Two doesn't fit into either of these categories because 2 is not an odd number and 2 is not a number greater than 3. So this one's a little tricky. So we just represented this by our Venn diagram. So they want to know this. Not. So what we are going to do is we're going to figure out A and B. So what is A and B? If we remember, A and B is what we find in this little region here. So A and B is 5. If we're taking the contrary of that, that means everything that's not a 5. So we have 1, 2, 3, 4, 6. So when we're taking the contrary of something or the complement of something, we are taking whatever is not in that something. So if it's a complement of A, it's whatever is not in A. If it's a complement of B, it's whatever is not in B. Phew, excuse me. Okay. We have some sort of, thank you. We have some laws that have to do with complements that help us to do some calculations quicker. So this was a bit of a pain in the butt to do this whole thing. But here we have some rules that talk to us about the complement and how we distribute the complement. So just like with when we had these problems, you could not say that this was x squared plus 3 squared. You couldn't just distribute this in. Something had to change. So it's the same thing here. If we have the complement, and remember the lines, we're doing this one. Remember the line on top just means prime. You can't just do this. It doesn't work that way. So what actually happens is when we're doing this, the A, U, B prime, it does distribute to the two different events, but this flips. So instead of having A or B, we have A and B, but in this case, the not case scenarios of that, which is not A and not B. Same thing here. It doesn't matter which direction it is. The prime or the not goes on to both of the different events, And this part, the union or intersection, flips. So this looks a little weird and freaky, and oh my gosh, how are we going to use this? Let's see. It's not as complicated as it appears to be. So we always start with our Venn diagram. Event A is rolling an odd number, lots of rolling odd numbers. So we actually have the same kind of diagram as we did before. So we have the odd number. We have the 5 in the middle because event B is rolling a number greater than 3. So we have 4, 6, and 5. And we have 2 on the outside. Okay. So this is my Venn diagram. We want A, U, B, the not, which we just found out was A, not A, intersection, not B. So what I'm going to do here is I'm going to figure out what is not A. What is not in A? Anything that's not in this bubble. So we have 2, we have 4, and we have 6. What is not in B? 1, 2, and 3. When I have this symbol, that means that I'm taking what's in both. So not gives me 2. Try another one. So we have event A is rolling a number less than 4. So I get 2 in here. So A would be 1, 2, 3. B would be an odd number are 1, 3, and 5. So here I'm left with 2. What's in the intersection? 1 is in both. 3 is in both. So here I'm left with the 2. Here I'm left with the 5. You could just write, if you got the previous question as a question, you could just write the answer. So what's left over here on the outside would be 4 and 6. So here we have A intersection B not. So this can be written as not A or not B. So what we're going to do is we're going to write the not A. So again, anything that's not in A. That leaves me with 4, 5, and 6. I also want the not B. What's not in B? 2, 4, and 6. When I take this, I'm adding. What do you mean, why did I choose 1, 3, and 5? For B, B is rolling an odd number. So what are the odd numbers? 1, 3, and 5 to make up B. And then because 1 is in both and 3 is in both, it goes into the intersection. Okay? So when I have this symbol, that means I'm adding them. So I'm just taking, so this part here, if I go back to the beginning, is I'm just taking everything that's in here. So I have a 2, I have a 4, I have a 5, and I have a 6. I don't write the 6 twice or the 4 twice because it's just one outcome. We don't double up. Questions? Do you understand how we got not A and not B? Okay. We have this relationship is our De Morgan's law. So when you have this, what this actually means is not A and not B. Okay. So when I have an and, that means that I'm just putting them together. So I want to create one list with all of these things in it. So if we go back to here, this means union A or B. What I do in this case is I add the two events. So we're 2 pages prior, 2 pages behind. So when you see this symbol, it means you add the 2 events together. When you see this, not that symbol, when you see this symbol, it means you want the intersection. Oh no, not that one. Hold on. When you want this one, you want the intersection. You want something that's both in A and in B. So you're taking the intersection here. So when you have the upside down U, you want the intersection. When you have the right side up U, you want to put the 2 together. So here, when I have the upside down, we're not on this problem anymore. Here, when I have the right side up U, that means that I want to put these 2 things together. Whoa, together. So I just take all of the numbers that are in here to create one big list. So I have a 2, the 2 goes there. I have a 4, 4 goes there. I have a 5, 5 goes there, and I have a 6, so the 6 goes there. And you're done. We have one last thing to talk about, 2 last things. We hopefully will get through both. We may not. All right. A difference event means that if I say A, this means minus, means the event A minus whatever is in B. And if I have this, what I want is the event B minus whatever is in A. So what does this visually look like? Event A is rolling an odd number and a number greater than 3. So we've already done this. So an odd number would be 1, 3, and 5. A number greater than 3 would be 4, 5, and 6. So the 5 would go in the intersection because it's in both. The 1 and the 3 would go over here. And the 4 and the 6 would go over here. And the 2 is left over. So when I want A without B, what I want is anything that's in A that does not also fall in B. So I'm cutting that out. So A without B becomes just 1 and 3. So what we want is we want whatever's in A that does not also fall in B. A student is chosen at random from grade 10. The students have just completed 2 exams, history and math. Event A would be that the student passes math. Event B, would that be the student passes history? And then the intersection in this case would be pass both. Whoever passed history and math. So if I have the A and the B, it's whoever passed history and math. So it would be however many students are in the intersection here. A without B, we have the same representation, pass math, pass both, and B, pass history. But when we take the A without the B, again, we are taking only the students that passed math, but taking away the ones who passed both. So I just want to know, actually, who passed math but failed history? And here we have the same thing. So if we want B without A, again, we want whatever is in B, but is not in A. So we want only the kids who passed history and not the kids who passed math. So they want passed history, but failed math. So just before we end, I just want to take a quick look at a couple of these. So we have some general laws for probability. So laws for probability. Probability of something has to be between 0 and 1. Period. A probability of an event. So sometimes in an event you have multiple outcomes. So to do this, to get the probability of that event, you just sum up the individual probabilities. For example, if we're rolling an even number, so the probability of even, so we have 2, 4, and 6. The probability of us rolling an even, rolling a 2 is 1 over 6. The probability of us rolling a 4 is 1 over 6. And the probability of us rolling a 6 is 1 over 6. So the probability of an even is I add it up, and then I can reduce, saying, well, the probability of an even is 1/2. The other way to look at this is the probability of A is the total number of outcomes in A. So if we double back to this example, how many evens do we have? We have 3. How many total outcomes do we have? We have 6. So either way, you can do this calculation, and still it gives you 1 over 2. I'm going to save this one for tomorrow, but I'll just look at these. The probability of the universal set. Remember, the universal set is everything, so the probability of that is 1. The probability of the empty set, so that's the empty set, meaning there's nothing, no outcomes, is 0. We're going to double back to this one and to this one tomorrow. But when you have, we'll go to 9, when you have 2 things that add up, remember we have A and A prime. Those are 2 things that when you put them together make up the whole universal set. So it makes sense that if I add the probabilities of them together, I'm going to get 1 because that's the probability of the universal set. So I'm going to save 6, 7, and 8 for tomorrow. And that's where we'll start up. For the handout for today and the assignment for today, some of it, most of it actually, you can't do. We're going to do tomorrow right at the beginning, conditional probability, which usually comes up as a part A or B question, usually a part A question on your exam. So it's super important for us, but we needed to be able to do Venn diagrams because sometimes it's presented as a Venn diagram and sometimes it's not. So those things have to be done. So tomorrow we're going to start off with that. So for now, you can go back and finish up Friday's handout. This afternoon, I'm going to be posting, like I said, I'm going to post the condensed list for the SIPROB, so you can take a look at that. I will also be giving you assignment 9 feedback this afternoon. And then tomorrow I'll do assignment 10 feedback. If there's any other questions, feel free to email me at any point throughout the day. Otherwise, have a great afternoon. Hopefully study for your SIPROB, super, super important. And if you have any questions, just send me a quick email.